The last example to cover in 3.1 day 1 is about analyzing this exponential function. You'll notice we're going to work with this one right here. So what you can do is simply graph this. So I've graphed it on my calculator. I chose a standard zoom window and it looks something like this. So I'm just going to copy that onto my page so I don't have to keep going back and forth with my calculator. It doesn't have to be perfect. I'm just going to get a general idea of what this graph will look like. So it's something like that. Now I can get rid of my calculator. So what we're going to do is analyze this for the things that you see over here. You can use this same list when you're when you're working on your homework, and not worry if there's some extra stuff in the book that the answer key has. So horizontal asymptote for an exponential function, it always has 1. In this case, the horizontal asymptote, it hasn't gone up or down. If it doesn't shift up or down at all, then the horizontal asymptote is, like usual, going to be y equals 0. Is it increasing or decreasing? Well, we always go from left to right, so this thing is traveling down. That is decreasing in this particular formula. The domain, what x values are included? Now it looks like this is shooting up, maybe has a vertical asymptote, but exponentials actually don't ever have a vertical asymptote. So everything goes on this one. The domain in this case is going to be negative infinity to positive infinity. For the range, that one is directly related to our horizontal asymptote in this case. It gets really, really close to 0, but never quite reaches. So we're going to go down to the lowest spot as 0, and then the y values are going up from there. We'll go up to positive infinity for the rest of the range. Extrema, that means mins or maxes. So we have to have an actual point that it bottoms out or tops out, and it never really does that here. It just keeps going down, and it goes up forever, so it's not going to have a local max. So there are no local extrema in this one. There are none. Continuity, remember, is just can you draw the thing without lifting up your pen or pencil? And in this case, that is true. It is continuous. Is continuous over the entire domain. Because there are no breaks or gaps anywhere in this one. Symmetry, is it symmetric over the y-axis? Does it flip over that way? And the answer to that is no. It's definitely not symmetry that way. There's also not rotational symmetry, so in this case we have none. And then in behavior, we talked about this in one of the previous examples for exponentials. It's pretty much the same every single time. For the left side, over to the left, we are going up forever, so that is positive infinity. On the right-hand side, we keep going this way, and we are ever approaching the horizontal asymptote of y equals 0. Those two are going to line up, and so the limit as we go out to the right is 0. That's all you'll need to have as far as a list goes in your assignment. So if the book has more aspects in the answer key, you can ignore those and just do the ones you see here.